What is this technology? They call a phenomena. We call it hyperlooping or looping. Why don't they want us to know about it? Why don't they even want to give it a name? We explain. First, let's look at the engineers who discover it but don't want to name it. Then we'll go into how to use it.
Phenomenon right at 90-something volts on all three legs. I'm completely disconnected from any electrical circuit. We come from the VFD to TB7 and then to the overloads and then to the motors. That's my TB7 right there. Here's my overloads. I'm not hooked up, but yet I can go from there to ground, 92 volts on those legs. I am inducing voltage through all of the VFD power feeds running to all the condenser fans through there. Because of all the wires running together and the magnetic fields around them, it's generating 95 volts of charge. To prove my point, let's drop out one of those circuits. Okay, it turned off. That drive is going to turn off. Our voltage reduced to 2 volts after I did that. And be careful, especially when you're dealing with inverter duty equipment. You can induce voltage and give yourself a shocking day.
Especially if we're experimenting. So, do you see where this says 38.8 volts going in? Okay, why is that doing that? Okay, and you see where it says 9.75 55 70 amps going in, and the battery is at 1378 77 volts, and it's saying that I got 132, let's say 3240.5. See that is going into this. This turns 12 volts, and that's getting warm. That takes 36 volts and drop it down to 12. So we can get this up here with that number right there working. Okay? That's where this is coming from. It's coming from this and not the battery. Because these are 36 volt batteries, which will not work with this MPPT solar charge controller. Okay? So, now that we did that, okay, so the battery is going up to this. Let's see, up to here, so we can follow that. So that's the battery. But now let's follow this battery down around here, out here, fused there, down into the battery here, and then it jumps over to this battery, and then this battery is going up. See, it's coupled here, going up, 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 and going into the solar cells. Okay, wait. Now, as we go back up here and we read, let's zoom back in. We read that we got, come on now, we read that we got 38.5 coming from the solar cell, which is the loop of the battery. You see that we got 10 amps going into this thing, and you see that we got 13.8 of the battery, and the battery is being charged by itself. Okay, I'm gonna go over this one more time. Okay, well, let's try to explain what's going on here. Okay, because we may get a little explosion here in this mess of wires. And let's move that up here. We have this thing. Of course, this is a battery. Okay? I'm going to hold this. So let's explain. This right here, because this battery, let's see if we can get that in the focus here. Let's focus just for a minute right here. So you see this 36.5 volts, okay? And standard current, they saying that that's what you're supposed to charge it at. Okay, but we're just gonna go with that. Okay, so you can read the specs if you understand these, understand any of this about the batteries. You understand what it's saying. Okay, so let's zoom back out. Okay, so we know that we have this battery hooked up. Okay, and this, because this is 36 volts and this is a 12 volt power supply, that means when you put more than 12 volts on there, it won't work. That's why I was going to send it back. I was hating it, but I had one of these. Okay, which is, see if we can get that into focus just a little bit. I don't have to. Okay, it knocks it down to 12 volts. Okay, so it takes 36 volts, it knocks it down to 12 volts, which we have hooked up, meaning that all these wires here, see, this wire is on the out part of this, and these wires are attached to this battery here. Okay, so it looks a little disorganized, but if you see it, let's see if we can keep that. This is hooked to the battery terminal here. This is letting only the 36 volts in here, only 12 volts is going through there. So it's drawing power that way. Okay. Now, if you see that this battery has a split on there, it has more than one, but this split, which is going back into the solar cell side, which is a loop. Okay, so now that we know that both these things are hooked up to the battery, let's see if we can get a reading on what it says here. So we're going to zoom in so we can get a good look at this, and we're going to say that, look, 39 volts, 0.7 is coming in from the simulated solar. And it says only 4.0, and somebody told me that's 25 amps. But that says 4.0 is coming from that battery. Okay? But the battery is showing being charged at 13, okay? 80, 79, 80, okay? So now if we take the load off of here, how long will that run? Which we was showing you.
What I just showed you has been known for quite some time.
Now the whole point is to actually take the solar cells to go to 39 to 40.
It's called
push
induction
into the battery,
and a lot of people
because remember,
this. So let's go
39 volts.
What we call looping today,
you need about 40
what
volts
they call a phenomenon that they known
to
for
actually
a
be pushing
very
into
long
the battery
time.
effectively. Okay?
Steve is the guy who made the TPU unit, which uses the same technology. It's called induction. And if you can look at the parts, you see it has a bunch of inductors in there. So it goes back to the beginning of this video and understand what the engineer is trying to tell you. And you see this type of thing has been around for ages. Now, understand that Nikola Tesla has a patent out with similar technologies. So what we're trying to say is that this technology is a phenomenon. No one has actually given it a name, but we did. And this is the name. Now that you understand that looping and hyperlooping are the same thing. Now with that, one day you're going to believe I am the guy who made up the name and the technology called Over Unity. Yes, I am the father of Over Unity. I'm writing books. I'm telling everyone, thank you for looking at my videos.